ठीक है ना. Hi all of you, good afternoon. Online, offline. Hi Arbaz, Ganesh, Mohini, Trichi, Neeraj, Harish, all of you, good morning. Acha, one thing, I hope all of you have or now have this book with you, all of you. Okay, so buy one and make sure you bring the book to class tomorrow. After 3-4 days, when I've covered substantial part, I want to make sure that you also read the books. ठीक है, so नहीं है तो खरीद लो. I gave you enough time, I think. So get your textbooks to class. Which book? Okay, this is Savindra Singh, Climatology. Shines here. You can make out, I think, isn't it? Yes. Yeah, by Savindra Singh, and any edition will do. Doesn't matter if it's an old one or new one. The pages don't change much. Okay, I have an older edition, this book, but any cover will do. Doesn't matter as long as it says Climatology, Savindra Singh. Okay, fine. That's one reminder to all of you. And for the older students, a reminder, Saturday is your submission day for the geomorphology synopsis. And I think I'll have your first discussion on the advanced content of enrichment on Tuesday. So we'll let you know the dates and the timing for that. So all of you be ready with it, because without the synopsis, I cannot move ahead. We also have one day required for the workbook session also. Okay, make sure you have done it. Fine. So let's start it with climatology. Quickly recapping whatever we have done. Yes, Gaurav. Yesterday I have started that. Now I'll explain. So quickly recapping climatology. You understand the composition. You understand the structure of the atmosphere. In the structure, we discussed the temperature basis as troposphere, stratosphere, mesosphere, and the thermosphere. You must have a fair sense about the heights also. Troposphere about 6 to 8 kilometers at the poles, about 16-18 kilometers at the equator, stratosphere up to 50 kilometers, and mesosphere up to 80 kilometers. And thermosphere is debatable kahan tak hai, but we agree it could be around 800 to 1000 kilometers. You understand the layering of the atmosphere. Then this layering is based on how is the atmosphere being heated. Okay, in some layers, the heating is from below. In some layers, the heating is from top. So wherever the heating is from below, the layers below are warmer. You go up, the layers become cooler. The layers below are warmer. You go up, the layers become cooler. In some cases, the heating is from above. In that case, the above layers are warmer. You come down, they become cooler. The above layers are warmer. You come down, they become cooler. So the trends of temperature are based on how is the atmosphere being heated. The main source of atmospheric heating. Atmospheric heating के लिए you have the visible spectrum, you have ultraviolet spectrum, and you have infrared. Visible and infrared largely is here and the surface. Thereafter, the atmosphere heats up. Ultraviolet largely here, and from here, okay, the layers will get heated up. So this is the warmest, a bit less warm, a bit less warm, and so on. So I believe this part is clear, all of you, not a problem. And you understand the idea that the radiations are of different, a capacity of the atmosphere to absorb. So we use a term, atmospheric window, the spectral range in which the atmosphere does not absorb at all, and that is the visible spectrum. 0.4 to 0.7 micron is the spectrum in which the atmosphere does not absorb the radiations at all. Baki sab mein you have some absorptions or the other. Okay? So this you understand. You understand what is ionosphere. Ionosphere is nothing but the thermosphere itself, but more in terms of the ion composition. Okay, ionosphere has a D layer, an E1 layer, an E2 layer, an F layer. F1 के भी 2-3 layers हैं, and the G layer. And the main role of ionosphere is a reflection of the radio waves. And we have medium waves, short waves. You know the names now. Okay, fine. So that's a quick revision. So one point, important point was, now you appreciate the fact that atmospheric processes of winds, of rainfall, atmospheric processes of events like cyclones, all of those are the consequence of the differences in heating of the atmosphere. It is because the heat is not uniformly distributed. That's why the atmosphere has this churning action. It tries to interact, it tries to move, it tries to mix. And the substances which are responsible for absorbing the energy, we call those as greenhouse substances. So the atmospheric processes जो हैं, they essentially are a mechanism to distribute heat across the atmosphere. And the greenhouse substances are the ones which absorb the solar heat. Okay. And these substances are carbon dioxide, water vapor, ozone, dust particles, we have methane, plus a host of other pollutants that include some of the nitrogen oxide compounds, and some pollutants are also sulfur oxide compounds. I'll teach afterwards something we called as NOx and SOx, nitrogen oxide compounds and sulfur oxide compounds. So these are the more important gases in atmospheric phenomena. So even if nitrogen makes up 78% and oxygen makes up 21% by volume, and argon makes up 0.93% by volume, these are not the main important gases or the substances for the heating of the atmosphere. So the atmosphere which plays a role in climate is a very small part of atmosphere that is responsible for all the phenomena we see in the atmosphere that manifests as the climate of our earth. Okay, so I think this part is fine, all of you here. we moved on towards concept of a heat budget. What is the heat budget? So heat budget, I said, is a way of studying how the solar energy is coming in, what are the processes involved, how the energy ultimately get absorbed, what type of work does it do, and ultimately, how does the energy leave the earth? So the heat budget is a way of understanding this movement of energy. Okay, so what is the heat budget? It is a way of appreciating how solar energy comes in, how it warms, and how it ultimately is lost. It's a way of appreciating how the atmosphere maintains its heat balance. The heat budget is a way of studying things. I said there are two ways you can study some of these interactions. One is study in terms of cycles, how things cycle. System 1 towards system 2, towards system 3, back towards 1, they're cycling. So we have water cycle, we have the oxygen cycle, carbon cycle, nitrogen cycle, phosphorus cycle. And the second way of understanding that is in terms of a mathematical, numerical statement. When I use the word cycle, it's more of a pictorial tool to imagine how things are circulating. आपको देख के आप imagine कर सकते हो from here to here, so on. But the heat budget is a numerical, it's a mathematical tool. Numbers में how much comes in, how much stays back, how much goes out. So this is one way of appreciating how the atmosphere is in balance. ये बहुत important है because see, if the atmosphere was not in balance in terms of its mechanisms and temperature, it would not support life. There is one temperature range in which life can survive. And even if we talk about कि climate change होता है, climate change, global warming, climate change, we have had ice ages. But the fact is, most of these climate change also was in a very narrow range of temperature. अब देखो ना, when I'm talking about Paris deal and all the rest, our focus is keep the temperature within 1.5 degrees, that's all. So when I say global warming, it's not that 15 has become 50 centigrade. It's so over, it's burning at the earth. ये 15 अगर 16 हो गया, you have all the processes that are getting messed up. When I say ice age, this 15 probably becomes 10, becomes 11, becomes 12. You have an ice age. So even if I'm looking at fluctuations of temperature, the fluctuations are not a great range. The fluctuations also are within 1 or 2 couple of degrees. Okay, so how does the earth maintain this? How is the earth not getting hot progressively? How is the earth not getting cold progressively? That is what the heat budget is trying to explain. So if I ask a question to you, explain the concept of heat budget. See, in your UPSC examination, lot of questions will be on the concept side. Okay, don't tell us and define alone. Definition में आप लिख दे एक sentence, समझाओ कि tell us why do I need this? Tell us what is it? Tell us why do we need this? Tell us what it tells us. Okay, what are the alternatives? Say the country called India and explain the concept called as Indianness. You must know society, history, polity. We have some aspirations as a society that's democratic. The concept is the idea, samjhao. What is a concept called as the heat budget. I hope that's fine, all of you. Any questions on this? Any doubts on this, online, offline? Okay. Then we said, how does the budget look like? Okay, so quick numbers here. 100 comes in. Reflection, 35. 15 absorption, 50 hits here. Sorry. 50 hits here. Okay, so this is the absorption quotient. What's going back? What's going back? This is the, sorry, reflection. This is the albedo. ये reflection है. This is atmospheric absorption, and this is the absorption at the surface. Now, one of you asking me, so if ultraviolet comes in, and that is 8%, then ये 15 कैसे हुआ? Okay, Gaurav, answering your question. Now see, what's coming in is ultraviolet plus a visible plus infrared. The visible spectrum more or less is moving straight, although some amount of visible spectrum also gets scattered. वो scattering component जो है वो इसमें आ जाता है. Okay, next. This 15 is not only ultraviolet. Okay, this 15 is the absorption by the atmosphere. A major component is ultraviolet by the ozone, but quite an amount is also the infrared component by the water vapor. When I'm saying water vapor absorbs, water vapor is absorbing in the atmosphere, some of it in troposphere, some of it in lower air, maybe some droplets, ice, etc., even in stratosphere. So 15 is not ultraviolet alone. Okay, 15 includes some amount of infrared also. Gaurav, is it fine now? So I didn't give the breakup in terms of the spectral range. Okay, infrared is significant, almost 50% is infrared. So this 50 coming in is part visible and part infrared. Fine, all of you? Okay, and I said I have deliberately made modifications on this. The reality is the number is not exactly these numbers. In fact, if you are curious, okay, watch here. This is page number 45 in my book. Okay, I'm just reading out some numbers so you know what we are talking about. Page 45 in my book. This is chapter number 3. आपके book में क्या page? Same page? 47. Maybe some of your books can have 47. Okay. Gaurav, उसमें जान मत डाल दो ना. Okay. उसका mechanism है. You read the more details. Ultraviolet A, B, C है. I know that. Okay. And not all of it gets absorbed in the atmosphere. Uska breakup, you have got lot of models. There is one model in page 45. There is one model in page number 47. Okay, don't get into that. Like for example, I have said the reflection from clouds alag hai, 27. A reflection from ground is 2. A reflection water vapor sent by space 6. ये सब मिला के it is 35. I have said 35 here. If you look at the other model, Okay. No, it's not showing me here. It's not showing on this. Here. So in this book, एक और टेबल में the amount sent back to space is यहाँ पर लिखा है 30 लिखा हुआ है. Can you see 30 here? Okay. So same book is giving you two different models. यहाँ 30 लिखा है. अच्छा, directly long wave outside I said 5. यहाँ लिखा है 7. Atmosphere absorbed I said 60. This one says 63. Okay. इसमें देखो, directly lost to space it says इसमें, yeah, yeah, lost directly to radiation. Okay. This one says 23. Okay. So you don't have to go into those numbers here. You understand the basic principles, that's all. Okay. So if you want the details, you can look up here. But I think, okay, this is convenient. I said, no, I've seen 2-3 models and I've taken up the closest approximations which are more universal. Okay, so you remember this number, 35, 15 and 50. The breakup is something I said avoid it. Yes. Okay, fine. Let's move on. The outflux, I said direct loss outside is 5. The atmosphere absorbs 10 absorption by sensible heat, 20 absorption by latent heat, and 15 is the net long wave radiations. So if you add up all of this, so 15 plus 20 plus 10 plus 5, this is 50. And 50 is what the Earth had absorbed. And ultimately this, all of this together, if you look at how much has the atmosphere gained, atmosphere has gained 15 plus 50 plus 20 plus 10 is 60, and this 60 is directly lost to outer space. 60 long wave radiation. And this is 50. And 50 is what the Earth's surface had absorbed. Okay? So that's how finally what comes in is 100. What's lost is 35 plus 60 plus 5. So this is 100. That is lost. What came in was 100 here. So what comes in at the atmosphere is equal to what leaves the atmosphere. What comes in at the surface is equal to what leaves the surface. Okay? Yes, correct, Pravash. This 5 is the direct, this is the direct long wave out radiation. There's a direct long wave out radiations. Okay, in the spectral range of, I said, 8 to 10 microns. This is the atmospheric window of out radiations. With the visible spectrum is atmospheric window of the incoming radiations. Yeah, that ठीक है all of you? And then we made that analysis that what comes in and what goes out is balanced for the whole system, but not for every latitude. And the balance is not maintained instantaneously. Okay, so it takes time. The earth absorbs, does some work, ultimately the earth will release. And that time for which it absorbs is what is the life process. That is the atmospheric process. So energy comes in, the plants absorb. Energy comes in, okay, the atmosphere starts to move. That's how the earth is maintaining the balance between the incoming and the outgoing radiations. All good here, all of you, all fine? Okay. Let's move on then. The next conversation is temperature patterns of the Earth's surface. Temperature patterns of the Earth's surface as in the troposphere. बहुत गर्मी है. Okay. Fine, no problem. What is the pattern of temperature on the Earth's surface? And when I say troposphere, I mean the lower troposphere. Because if you look at the atmosphere, एक है आपका vertical pattern. This vertical pattern I have explained. So if I look at the temperature pattern, one is the vertical pattern of atmospheric temperature. ये समझा दिया आपको मैंने. Lapse rates, okay, cooling with height troposphere, warming with height stratosphere, and so on. Then there is a horizontal pattern. That's what I'm discussing now. What's that question, Shivam? Is there a feedback loop? Absolutely, Shivam. The clouds, the water, okay, the atmosphere is, okay, converting energy back and forth. So yes, these changes are not linear. There are feedback loops. That's why the atmosphere works like a system. A impacts B, B impacts C, C impacts D, maybe C impacts A back again, D impacts B back again. So yes, so we don't enter that details. We don't need it at this stage at least. We just accept it, that's how it happens. Okay. So the vertical pattern of temperature you understand. That's about the lapse rate. It includes NLR concept. It includes the ELR concept. Okay. Now I'm discussing the horizontal patterns on the surface and the lower atmosphere. Okay. Now first point here, the pattern temperature ke liye, the first point is the primary source of the heat and all temperature is the sun. The primary source of heat and whatever temperature we have on the surface is the sun. Okay, I made a statement yesterday. 99.99% of the energy that we have that warms atmosphere and surface is the sun. We do have some energy being added by volcanism, but we ignore that. That's not enough to talk in terms of patterns of temperature. The sun is the main source. Achha. Now, if Earth's surface was flat, and this is the atmosphere that we have, and if this was a sun, because the sun rays come from very far off. All the rays of sunlight are parallel, okay, and every place would have received the same amount of energy at the same angle. Agar Earth's surface flat hota to, if Earth was flat, then every location of the Earth facing the sun would receive the same amount of energy, and there would have been no temperature variations. But the reality is, Earth's surface is curved, and the atmosphere is also curved like this. So if I have the sun shining, okay, the rays are all coming straight. The rays are all coming straight. Okay. There are parallel straight beams of rays. But what happens is, in the lower latitude, the sun rays hit the surface at 90 degrees. If I go up here, the sun rays are hitting the surface at a slant angle. Plus, this energy is in a smaller area. Think of a band of sunlight. This band of sunlight is heating this area. If I see the same band, say ye wala band, so look at this band here, same band. In this case, it is heating a larger area. Can all imagine here? Because slant hai. This area is less, this area is more. Plus, the distance inside the atmosphere, the distance covered is this here. Yahan par, look, yahan se yahan tak distance hai. This is much longer distance in the atmosphere. So what happens is, if I go away from the equator towards the poles, the energy on the surface is less. Less because of three reasons. One is less because the angle is slant, less because spread over larger area, and less because the distance through the atmosphere is more, so there are more losses in the atmosphere. So what happens is, okay, the lower latitudes, in this what happens is, the lower latitudes have a higher intensity of insolation. The high latitudes, they have lower intensity of insolation. Consequently, you move away from the equator towards the poles, the temperature starts to fall. Why is it cold towards the poles? Why? Poles are cold because, okay, the energy at the poles is far less intense than the energy at the equator. But agar flat surface hota, then I would not have these type of variations. Okay? So your second point. The first point is the primary source of heat is the sun. The second point, because of Earth's spherical shape, because of the Earth's spherical shape, the high latitudes receive less intensity insolation. The high latitudes receive less intensity insolation. Okay. Whereas the low latitudes receive, okay, a higher intensity of insolation. And within bracket, you can mention this. In the higher latitudes, in the bracket mentioned, in the high latitudes, the intensity is less because of, in the high latitudes, the intensity is less because of, number one, slant rays. Number two, Number 2, insolation spread over larger area. Slant rays, the insolation spread over larger area. And because of a greater thickness of atmosphere, and because of greater thickness of atmosphere, the insolation crosses. The greater thickness of atmosphere, the insolation crosses, and therefore, more atmospheric losses. And therefore, more atmospheric losses. Okay? So, the conclusion of this is that the insolation received, therefore, next point, इसी point में next paragraph, therefore, the insolation received is a function of the latitude. The insolation received is the function of the latitude. When I use the word function of the latitude, I essentially mean the latitude is an important factor. Okay, that's why the low latitudes are warmer and the high latitudes are cooler. Okay, so the insolation received is a function of latitude, and therefore, away from the poles in general, away from the poles in general, the temperatures reduce. Away from the poles in general, the temperatures reduce. All good here, all of you? Yes. वो कम होगी वो अलग रीजन है. आप जो कह रहे हो, your friend is asking us, at the poles the thickness is less. When we say that, what I mean is a flat surface, and this is the equator. You are talking about this one, correct? What I am saying is, at the equator, the sunlight comes straight. At the poles, the sunlight comes at a slant angle like this. So, even if the thickness is less, the distance covered inside this is much more than the distance covered here. Is it okay, all of you? Huh? Yes. मैंने क्या पोस्ट बोल दिया आपको? I'm sorry. Away from the equator, yes. Right. That was checking your alertness. Okay. So good, nice. ठीक है? I'll take you more seriously now. ठीक? So as we move away from the equator, the temperature reduces. Pravash, did I explain your doubt now? The same doubt your friend asked here. Away from the equator, the temperature will start reducing. That's equator. These will have a higher temperatures. Away from this, the poles will have lower temperature. So temperature is a function of the latitude. Rectify kar lo. Okay, fine. Did you all understand this concept here? That yes, if I look at convection, then the tropopause is at a higher level at equator, and the tropopause is at a lower level at the equator, at the poles. But then tropopause is not the only layer, no? We have, okay, the stratosphere also, the mesosphere also, we have the thermosphere also, and so energy comes from very far away. So from very far away, it receives straight sunlight here, और यहाँ पर it is receiving a slant one here. So even if the thickness is more here and less here, look at the distance covered. This is a distance covered for the equator, and this distance is covered for the poles. So more distance covered means more losses. So I showed this to you on a curved surface, like this. This and this is a long distance covered till the poles. यहाँ से यहाँ तक और ये वाला यहाँ से यहाँ तक. Wait, Prabhu, slowly, gradually. Abhi ruk jao. The first point is done. The next point. Next point. However, there are modifications in this general pattern. However, there are modifications in this general pattern. So when I make a statement, the poles are cooler than the equator, it's a sweeping statement. It is not accounting for variations on the surface. Okay. But there are modifications. There are modifications to the latitudinal pattern. There are modifications to the latitudinal pattern. So modifications includes number one, okay, the northern hemispheres are warmer on an average compared to the southern hemispheres. The northern hemispheres are warmer at an average compared to the southern hemisphere. Why? Because northern hemisphere has more land. Okay, more land, the heat gets absorbed at the land faster, plus the oceans are not able to mix the heat very well. Okay, therefore the northern one has more heat. South mein the heat gets very well distributed. So northern in general has more warm conditions than the southern hemisphere. That's one. Number two, the equator receives the highest insolation. The equator receives the highest insolation on an average. The highest insolation on an average for all the latitudes. On average, for all the latitudes, equator receives the highest insolation. But because equator has more clouds, the amount of insolation reaching the surface, is somewhat less. The insolation reaching the surface is somewhat less, and therefore the equator is not the hottest latitude. Therefore, the equator is not the hottest latitude. Okay. So equator mein in general you are receiving more energy. Why? Because equator does not have seasons. Throughout the year, the sun is not very far away from the equator. But equator mein strong convections hain. So equator has strong convection, rising air. The clouds are massive. The insolation will get reflected. It gets reflected. So equator is hot, but not the hottest area. Okay. The next one. Okay. The subtropical latitudes, around 30-35, to sometimes as much as 40 degrees, to sometimes as much as 40 degrees north and south, have a high pressure conditions, have high pressure conditions. Watch here. If air is rising, all of you watch, if air is rising, ये rise करेगा मतलब क्या होगा? The air is less here. So this will become low pressure. If air is sinking, something is pushing the air down, it will become high pressure. Whenever I have rising air will go up, will become cold, and I will have cloud formations. Wherever air sinks, there will be no clouds. That's a very basic elementary geography you must know. Okay, so rising air, low pressure, clouds, I can have reflection. Sinking air, high pressure, no clouds. The insolation can be very powerful on the surface. It can be very, very strong insolation on the surface. So what happens on the earth is, at the equator, there is strong convection going on. There is low pressure. But at somewhere here, say 35, 40 degrees approximately, or 30 degrees mein, air is sinking here. This is a high pressure. There are no clouds. No clouds, therefore, the insolation can come in very strongly. The sunlight can come in very, very strongly. Yahan par, it comes in, some goes in, but some also gets reflected because there are clouds here. So the atmosphere is not the hottest at the equator. It is the hottest at the margins of the tropics where we have high pressure. Okay? Write down the high pressure, write down the high pressure at the subtropics, the high pressure at the subtropics have clear skies. The high pressure at the subtropics have clear skies and therefore very strong insolation. And therefore very strong insolation. Yeah, tell me, Pravash, what is that you are talking about? What's the doubt, Pravash? Tell me. Chalo, you can type it there. I'll address it. Okay? So, in general, I said the temperature has a pattern of latitude. That's one point. The northern hemisphere is warmer than southern hemisphere. That's second point. The third point is equator is not the warmest. And the fourth point is the subtropical areas are the warmest. Yes, Pravash, that's right. Equator receives the highest insolation on average for all latitudes. That's right. Okay. And then उसमें difference भी है. Equator पे above atmosphere, equator पे at the surface. So there are differences there. But on general, we can say that along equator, we will have the maximum amount of insolation on an average. Latitudes, not longitudes. It's all about latitudes. Okay, this is latitudes. I'm not comparing like this. So if I compare all the latitudes, equator has the maximum on an average, the insolation. But not all of it reaches the Earth's surface. Okay, right, next point. The other modifying factors are, now A, B, C, D karo. One is the land water differential. The other modifying factors are land, water differential. Because of this, the coastal areas are moderated and the continentality areas will have extremes of temperature. Land water differential, कि अगर there's land here and water here, a difference between them. The coastal areas will have moderation, not very hot. The water will have, okay, moderations. But inside the continents, yahan par, it can be very hot in the summers, it can be very cold in the winters. We call that as continentality. The continentality locations away from the coast, the coastal areas have moderation. The continentality locations, which is away from the coast, there will be extremes of temperature. The summers can be very hot, the winters can be very cold. Typically what's happening for Delhi, parts of Rajasthan, away from the coast, they can be pretty extremes. That's called as land-water differential. The next is local winds. Local winds. So wherever we have warm conditions, okay, warm winds, wherever we have warm winds, the temperature is more than the average. Wherever we have cold winds, the temperature is less than the average. Example of warm winds, 2-3 names. There is Loo in northern plains of India, a warm wind called as FOHN, Fawn. In the Alps hai a warm wind called as a Chinook in the Rockies. Okay, abhi likh lo. Ultimately I take up local winds to understand that. Loo is in the northern plains of India. Fawn is in the Alps of Europe, in the mountains called as Alps. Chinook are in the mountains called as, or slopes called as, Rockies mountains in North America. So wherever I have warm winds, I will have more temperature than average. Wherever I have cold winds, example of cold winds, one is Mistral. Mistral is in France. And in France, along a valley called as the Rhone River Valley. Mistral is a cold wind in the Rhone River Valley of France. A cold wind called as Bora, B-O-R-A. It impacts the regions along the Adriatic coast. Adriatic coast is Serbia, Albania, Croatia. Okay. Bora is along a coast called as Adriatic coast. Okay. So wherever we have cold winds, I will have, yes, there are many more winds. There's one wind called as Gregale. Gregale, it impacts Greece. It impacts Greece. So 3-4 names are okay for now. Warm winds, warm conditions, cold wind, cold conditions. When the temperatures are warmer than average, because zyada hai, we call this as positive anomaly. Anomaly means some deviation. The temperatures are more than the normal, we call that as positive anomaly. When temperatures are less than the normal, we call this as the negative anomaly. Okay? So local winds, they can modify the temperatures. Achha, next. The impact of currents. Wherever we have warm ocean currents, again you will have positive anomaly. Wherever we have cold currents, we will have negative anomaly. Examples of warm current, 2-3 names, if some of you know this. Something called as the Gulf Stream is a very powerful warm current. Okay. We have a warm current called as North Atlantic Drift. The Gulf Stream impacts the Atlantic coast of US. The North Atlantic Drift impacts Britain and UK. Okay. Cold current example, a very powerful one called as the Peru current. It impacts the coasts of Peru and Chile. One more cold current is the Canaries cold current. It impacts the coasts of northwest Africa. A cold current called as Benguela current. This impacts the coasts of Angola and Namibia. Okay. So cold currents, if warm current we have positive anomaly, a cold current has a negative anomaly, whatever names you know. I just gave very elementary names. If you know more, you can write that down also. I gave 2 examples of warm currents. One is Gulf Stream. It impacts the Atlantic coast of US and the North Atlantic Drift. It impacts the UK coast. Then we have cold currents. Cold currents impacting Peru coast. Okay, Peru coast or Peru current along Peru coast and Chile coast. This is the western coast of South America. Canaries current. So if I am drawing the diagrams here, quick small sketches. This is South America here. I have a cold current here. This is the Peru current. If this is Africa, I have a cold current here. This is the Canaries current. I have a cold current here. This is the Benguela current. Okay. For North America, this is Florida. I have a warm current here. This is the Gulf Stream. Gulf Stream. So small sketches, your answer must have South America, North America and Africa. The cold current, warm current and the anomalies. Yes, the Labrador current is a cold current, absolutely. Oashio is a cold current, yes. So fine, you know some of that. I'm moving on. So warm wind and cold wind, warm current and cold current. Next, the third one, right? The fourth one, kya hai? Whatever, theek hai. The fourth one. The impact of altitude. The impact of altitude. Okay. With increasing height in the troposphere, there is negative anomaly. Okay, we have the lapse rate. Okay, with the rising height in the troposphere, we have negative anomaly. That's why the hill stations are cooler. The hill stations are cooler because of the effect of altitude. Okay. The fifth the effect of upwelling. Upwelling basically means the deep ocean waters are rising and they bring very cold waters to the surface. We call that as upwelling. Okay? So when the water comes from the deeper parts of the oceans, so this is the ocean surface, this is the continent, ये ocean floor है, the water coming from the deep towards the surface. From the deep towards the surface. Surface temperatures are generally around 27 centigrade. And bottom waters are about 3 to 4 degrees centigrade. So when this rises up, when the deep ocean waters rises, it brings very cold waters to the surface. So upwelling will always create negative anomaly. Upwelling will create negative anomaly. And for now, let's remember one location where this happens. You can remember for now, the western coasts of tropical lands or the eastern tropical waters have upwelling. You remember this. The western coasts of tropical lands and the eastern tropical waters have upwelling. The western coast of tropical land बोल लो या फिर बोलो eastern tropical waters. Okay. And for now, just mention this here. That's because these areas have offshore trade winds. These areas have offshore trade winds. Okay. And the upwelling also contributes to the formation of cold currents. ये लिख लो अभी आप. Why this happens? Because these areas have offshore trade winds. Offshore trade winds, and this upwelling also contributes to the formation of the cold currents. Formation of the cold currents. So what I mean by this is, so if this is a continent here, this is another continent here, and that's the equator, and this is the tropic of Cancer. This is the Tropic of Capricorn. Tropic of Cancer, Tropic of Capricorn. Then in this part what happens is, this is land ka western side here. This is the land ka western side. Here the winds are coming from the land towards the sea. The winds are coming from the land towards the sea. We call this as offshore trade winds. Okay. Same thing here. The winds are coming from the land towards the sea. These winds are called as the northeast trade winds. We call this as the southeast trade winds. So these winds are coming from the land towards the water. So what they do is, when they come like this, they will remove the surface water. Okay. तो यहाँ से पानी हटा रहा है. So if I draw a cross section here, imagine this is land and this is the water. And the wind is coming like this. This wind will remove the water. Therefore, the cold water from deep is forced to rise. So in these parts, you will have upwelling here. You'll have upwelling here. You'll have upwelling here and upwelling here. And I said this is water ka eastern side or land ka western side. I hope for most of you आपका east west ठीक है, right? Okay, वो हो जाता है कभी-कभी, है ना? This is north, south, east and west. I have a problem in this. मेरा east west गड़बड़ा जाता है. Okay, so I know how you might feel, but don't worry. Okay. There are some geniuses who miss this. Okay, so perfectly acceptable. So the left hand side is the west. The east side is the east. Or the right side is the east. So अगर water है, इसका right side is the east. अगर land है, the left hand side is the west. And that's what we wrote here. We wrote, that's because western coast of the tropical land or say eastern tropical waters, same thing. ठीक है? These areas have upwelling, and इसी area में you also will have the cold currents. ये cold current है, ये cold current है. This also is a cold current. This also is a cold current. Okay? They will have cold currents. So you have the Californian cold current, the Peruvian cold current, the Canaries cold current, the Benguela cold current. So all of these are cold currents also. So upwelling will result in negative anomaly. Komal, that's for now. How are the cold current forms? This is one of the reasons why the currents are cold. At the trade wind? वो बाद में. You have gone way ahead in terms of El Nino. अभी इतने काफी है. Anybody else? No. यार सब कुछ थोड़ी जोड़ दोगे. कोल्ड करंट भी हो गया, एल नीनो भी हो गया, आपका फिशिंग भी हो गया, साढ़े पार्टी बना लो. ओके लाइफ है, क्या है बोला, सानी. ओके कंट्रोल अभी बाकी है. ट्रेड विंड ड्रैग द सरफेस करेंट्स, करेक्ट. वाटर, करेक्ट. ठीक है. So that is the effect of upwelling and the cold currents. The next point, क्या point number 6 है, क्या है? 5 तो जा चुका है यार. 6. Okay. The next one is the effect of slope aspect. The effect of slope aspect. If I have a mountain, I have a sun here. This is the sun facing slope. And this is, okay, behind the sun, or the slope away from the sun. Not behind, say it is away from the sun. Facing the sun is called as adret slope, A-D-R-E-T. Away is called as the U-back slope, U-B-A-C. The U-back slope, the adret slope and the U-back slope. Parvaz, yes, that's one pattern, but there are other cold currents also. For now, you remember that's one of the important reasons why we have cold currents. The adret slope will always be warmer. This is positive anomaly. And the U-back slope will always be cooler. It is the negative anomaly. We call this as the effect of slope aspect. No, Navya, that's wrong word. When you say windward or leeward, you're talking about a wind. ये wind नहीं है. In this case, the wind can be like this is windward, and this is leeward. The wind can be like this can be windward, then this is leeward. Whenever I use the word windward, leeward, I'm talking in reference of a moving wind. यहाँ पे wind का role नहीं है. This is simply the face towards the sun, the face away from the sun. All fine here? So, if this is the earth, and say I have a mountain here, I have another mountain here, and I have a sun here. ठीक है? This is the northern slope, this is the southern slope. This is the northern slope, this is the southern slope. South pole, north pole. अब बताओ इस केस में, okay, which is the adret slope? South is the adret slope. This will be the U-back slope. इस केस में बताओ, north is the adret slope, south is the U-back slope. Is it okay, all of you? This is the rule. Okay. South facing slopes of northern hemisphere have positive anomaly. North facing slopes of southern hemisphere have positive anomaly. This has positive, this has positive, this has negative, this has negative. South facing slopes of northern hemisphere and the north facing slopes of southern hemisphere, their adret will have positive anomaly. South facing of north and north facing of south. Okay. And north facing of north and south facing of south, both are negative anomaly. So Himalayas mein, the side towards India is what slope? It is the adret slope. The adret slopes will have more forests. This will be relatively drier, less vegetation. So Indian side is having more forest than the Tibetan side. Okay? So how does the slope gets modified? How does the temperature gets modified? Because of local factors. वहाँ भी upwelling होता है, but of different kind. But वहाँ पर आप warm मत लिख देना बस. You just write for offshore winds as upwelling. Yeah, anybody else? Any doubts here? So we have, if I'm summarizing the patterns of temperature, I said the primary pattern of temperature is latitudinal, but there is a difference at the equator. It is not the warmest. The northern hemisphere is relatively warmer. Then we have the effect of currents, the effect of winds, the effect of altitudes, the effect of upwelling, the effect of slope aspect, and the effect of land water differential. In all these cases, you'll have positive anomaly and you'll have negative anomaly with examples. Take a summary of how is the pattern on the earth and atmosphere changing at different locations of the earth. The primary pattern is latitudinal. Equator is not the warmest. The northern hemisphere is relatively more warm. And other factors of anomalies are current, winds, altitude, upwelling, slope aspect, and land water differential. All of this, by the way, I did something here. I did not mention the anomaly thing here. If I have got land, if I've got water, okay, coast में क्या होगा? Positive or negative anomaly? Along the coast, what will we have? Positive or negative anomaly? Huh? Day and night, nothing, none. नहीं होगा anomaly, but आप कुछ लिखोगे वहां पर. This is like this. If it is summers and it is low latitudes, okay, it is negative anomaly, not as warm. If it is winters and if it is high latitudes, you will have positive anomaly. Okay, I hope you got the point here. So you can't write in general. For the land water difference, okay, अगर summer time है and tropical areas भी है, this will not be as warm. That's why it is negative anomaly. Water will cool it. अगर winters है or it is high latitudes, then you will have positive anomaly. The whole area is very, very hot or very, very cold. इसका opposite होगा. Interiors, if it is winters, very strong negative anomalies. If it is summers, it's very strong positive anomaly. ठीक है? So for the land water differential, the coastal areas, okay, if it is tropics or it is summers, then it is negative anomaly, warmer than the average. If it is high and mid latitudes or it is winters, it will be positive anomaly. That's why Chennai, Kolkata, okay, or Mangalore or Mumbai, they do not have severe winters. They're warmer than the winters. And summers, they're never very hot. They're cooler than the other area of summers. So this will have positive, this has negative. Whereas continental locations, this is in the interiors of the land. The summers can have very positive anomaly and the winters can have very negative anomaly. Take all of you. That's why I did not write in general. I mean, this is something you infer, okay, not something, a concept that you will make a mistake otherwise. Can I move on from here now? Okay, now, next. Isotherm patterns on the globe. So this pattern of cold and warm conditions, how does it look like? What do you see that as? दिखने में कैसा है? If I show on a map, how do you show that? You show it through isotherms. So isotherms are what? They are lines joining places with same temperature, assuming the locations are at the sea level. This is an important point. Isotherms are lines joining places with same temperature. Assuming that the locations are at the sea level. What I mean by this is that these lines will not capture the effect of altitudes. अगर आपके पास यहां पर mountain है भी, I'm assuming there's no mountain. There are no height variations. All are at sea level. अब बताओ what is the temperature? That's why we say that isotherms do not tell us the actual temperature of a place, because all temperatures are reduced to the sea levels. What I mean by that is, say this place temperature is 20 degrees centigrade. There's a mountain here, and this place has 10 degrees centigrade. So when I plot the isotherms, I will remove the height and say this height of the mountain is 1 kilometer. What I'll do is, I'll say mountain hatao, फिर ये temperature जो है 10 minus 6.4, it is 3.6 degrees centigrade. So I'll assume that this landform is actually nothing but a place that has this and a place that has this temperature. Okay? So isotherms never depict. कैसे? ओए, कैसे किया? 10 minus 6.4. Oh, sorry, I've added, sorry. Yeah, this is plus 6.4. Correct. This is warmer, right? So I'll add this, it is 16.4 centigrade. Okay, so I will show this surface as 16.4 centigrade. You rise up 1 kilometer, reduced by 6.4. So this 10 is actually, okay, the reduced temperature because of altitude. The isotherm में हम ये नहीं बना सकते, हम ये बनाएंगे. So add a point here. The isotherms, yeah, Gaurav, correct. The isotherms therefore do not depict. The isotherms therefore do not depict the actual temperature of a place. They don't depict the actual temperature of a place. All locations are assumed to be reduced to the sea level. All locations are assumed to be reduced to the sea level. Take assuming, I'm assuming a simple case where the lapse rate is 6.4 per kilometer. In this case, I've done that. Okay, let's move on. So, if there was no modifying factor, if the earth was smooth, homogeneous, no land-water differences, no warm currents, no cold currents, in that case, the earth would have isotherms east-west parallel to the latitudes, because along the latitude, the sunlight is the only factor. So all places will have the same temperature. All places have the same temperature. Write down, first point. If temperature pattern was a function of, latitudes alone, if temperature was a function of latitudes alone, the isotherms would have been straight parallel lines. The isotherms would have been straight parallel lines along the latitudes. straight parallel lines along the latitude. ठीक है? Next point. But there are modifications. But there are modifications that create anomalies. There are modifications that create anomalies. Next point. Now watch here, listen. Say I have a surface, say two surfaces here. Say this is 10 degrees centigrade. It now becomes 5 degrees centigrade, and this now becomes 0. Okay? And say some other place, this is 10 centigrade. It cools very fast and becomes 5 here itself. Very fast cooling, it becomes 0 here. So when the temperature changes happen slowly, the spacing between the lines is more. When the temperature change happens very fast, the spacing will be less. Plus, if there is land here and water here, there will be irregular isotherms. Is only water homogeneous hai, the lines will be more smoother. So because of the land water difference, the northern hemisphere has more irregular lines. Plus north mein the lines are more packed. Okay, why? Because mixing ho nahi pa raha hai. In the southern hemisphere, lines are more smooth and more evenly distributed. Water will spread the temperature more. That's why the gap becomes more. Right now, the northern hemisphere has more irregular isotherms. The northern hemisphere has more irregular isotherms, and the spacing is narrower. And the spacing is narrower because of the land effect. Because of the land effect. Whereas the southern hemisphere has more even spaced lines. The southern hemisphere has more even spaced lines and more smoother lines. No problem here. So, see, these notes are almost like answers. If they ask you, write a note on the temperature pattern of the globe. Write a note on the isotherm pattern of the globe. ये almost straight answer ही है. That if there was no difference of land and water and the surface was homogeneous, the lines would have been all straight, smooth, evenly spaced lines. But what we actually have is, northern hemisphere में more irregularities हैं. The lines are much more closer. They are sharper here. यहाँ पर they are more evenly spaced, more far away, and more smoother. Because of the land-water difference. Okay. Next point. Now first listen to this, then I will say that's the earth. For whatever reason, say there is something here, यहाँ पर कुछ है, either land है, या maybe warm water है, or maybe warm air hai. For whatever reasons, let's assume this is warm and the water is relatively cooler. ठीक है? Don't write this down, just listen to this once. Say this is some surface. Okay. Say this is, for some reason, it is warmer than the water outside. Let's assume the isotherm on this part is say 20 degree centigrade. Because ये warm है, तो यहाँ पर can I assume say it is, say this is 25 degree centigrade. ठीक है? It's warmer for whatever reasons. ये 20 है, as I go towards pole, it become cooler. Say this is 15 centigrade. ये इससे warm होगा. This is 20. It becomes even more cooler. Now it becomes 10. And this is warmer than 10. Let's assume it is 15. This 10 becomes cold and becomes 5. The 15 becomes cold and becomes, say it is 10. यहाँ 20 है तो यहाँ पे 20 रखो आप. यहाँ 15 है कि 15 here. 10 here, so 10 here. 5 here, so 5 here. Now join the lines with same temperature. What I get is 20 comes here, 20. 15 comes here, 15. 10, okay, it comes here, okay. ये और ऊपर जाएगा ऐसे. I hope that's fine, all of you. When I say this is warmer than this, क्या बोलोगे आप? Anomaly क्या है ये? If this is warmer than this here, so क्या बोलोगे आप? Positive anomaly. This is the positive anomaly. ठीक है? अच्छा. Same logic में, let me assume कि वैसे ही यहां पर land है और यहां पर something which again is warmer. This ये warm है, assuming कि ये भी warm है, southern hemisphere. Same pattern. I have 20 here. I will have 25 here. Okay. If I have, okay, this is 20, 25 here. This is say 15. Okay. This probably is now 20. This is 10. This is now 15. This is now 5. This has now become 10. Same 5 is here, same 10 is here, same 15 is here, and 20 is here. Again join the lines. 20, 20, 15, 15, 10, 10, 5 and maybe 5 here. If this is warmer than this, मैं क्या बोलूँगा इसको? What will I say here again? Positive. And this warm can be warm current, can be warm waters, can be land in the summers. So can I make a rule now? If there is positive anomaly, the isotherms will shift towards the poles. अगर north में है तो north pole, अगर south में है towards south pole. That's the rule. So isotherms, yes. That's a उल्टा लो आप. If the water is warmer, land is cooler, or this surface is cooler. Reverse करो. If this is 20, इसको रखो 15. If this is 15, keep this as 10. If this is 10, keep this as 15. ये कहना चाह रहे हो, right? Join this. 20, 15, 10. अब ज्वाइन करो. ये ऐसे आएगा, ये फिर ऐसे आएगा, ये फिर ऐसे आएगा. This is negative anomaly. This land is cooler. That's negative anomaly. So for negative anomaly, the bend of isotherms is towards equator. For positive anomaly, the bend is towards the poles. That's about it. Yes. Because if you look at the average, okay, land is what becomes cold fast and warm fast. Water remains more or less same. So the average I take up, I take in average in terms of what does not change much. If there was no land, then this would have been the isotherm. Land is disrupting the patterns. One. Number two, Earth में ज़्यादा क्या है? पानी है कि land है? Water is more. Okay, almost 71% is water. So averages we take in terms of water and then tell land is cooler or warmer. ठीक है? Anybody else here? So your answer, I need only one sentence, which is positive anomalies, the isotherms shift towards the poles. Negative anomaly, they shift towards the equator. And that positive can be any reason. Warm water hai, sorry, warm currents hai, positive. Okay, or warm because of warm wind hai, wo bhi positive anomaly. Warm because land has summers hai, again positive anomaly. ठीक है? The next point write down. The isotherms can shift. The isotherms can shift and get distorted. The isotherms can shift and can get distorted because of temperature anomalies. They can shift or get distorted because of temperature anomalies. Positive anomalies shift the isotherms polewards. Positive anomalies shift the isotherms polewards. And negative anomalies bend the isotherms equatorwards. Negative anomalies bend the isotherms equatorwards. The same thing your books will write as, लिख लो आप, okay, isotherms on the land, isotherms on the land in the summers. क्या बोलेंगे आप? Bend polewards. Isotherms on the land in the summers will bend polewards. Isotherms on the land in the winters will bend equatorwards. ठीक है? So what does the isotherm pattern look like on the globe? Straight lines नहीं होते हैं, irregular होते हैं, spacings can vary and they can shift north and south. Okay, now there's one more concept, write it down. The concept of thermal equator. The concept of thermal equator. Essentially the line that joins, the thermal equator is the line that joins locations with highest temperatures, associated with the position under the sun. Associated with the position under the sun. It's like this is the earth and the sun is shining here. Then this is where we'll have the warmest conditions. In the summer season, the sun has gone towards the tropics. This is where we will have the highest temperatures. In the winters, the sun has come down south. Now this will have the highest temperatures. The thermal equator वो line है that joins places with the highest temperature and linked to the locations under the sun. The thermal equator, next point, the thermal equator is on an average, the thermal equator is on an average in the northern hemisphere. Is in the northern hemisphere. समझ में आ रहा भाई? Because north has more land. Okay, land is more warmer. So on average, it will be more towards the north. The thermal equator on average is in the northern hemisphere and can shift north and south with the apparent motion of the sun. It can shift north and south with the apparent motion of the sun. So as the sun goes north and south, the equator also will start moving north and south. But on average, because the north has more land, the thermal equator will be more towards the northern hemisphere. इसे में ऐड करो. Okay. Next point लिखो आप. The thermal equator is associated with ITCZ. ITCZ. It is intertropical convergence zone. Okay? The thermal equator है, because it is an area of hot conditions, it will have a low pressure, because of which the winds will come towards the low pressure. The winds will come towards the low pressure. So, because the winds come towards and they converge, we call this as the ITCZ. Okay, write down this point, likho aap. The ITCZ is a band of low pressure. ITCZ is a band of low pressure because of solar heating. Because of solar heating. The low pressure attracts winds to itself. The low pressure attracts the wind to itself, and therefore it's called as the convergence zone. It's called as the convergence zone. The ITCZ attracts the trade winds. Attracts the trade winds. So I'll talk about winds, maybe 1 or 2 classes more. So we have some winds here. The north wale, we call this as the northeast trades. This we call as the southeast trades. So these winds, they come and converge. They come and meet here. So ITCZ is that. So more or less, the ITCZ is coinciding with the thermal equator. And just as the thermal equator on average is in the north, the ITCZ also is towards the north. Okay? So like the thermal equator, the ITCZ is also okay, on average located in the northern hemisphere. On average, it is located in the northern hemisphere. And within bracket mention, the movement of ITCZ, is important for climatic patterns called as monsoons. The movement of ITCZ is important for climatic patterns or climatic types called as the monsoons. All good here? Can you go back and check if you want to ask me something, all of you, quickly? Just scan through once, all of you. What does the temperature pattern look like? What are the anomalies? What are the averages? And how do we depict the patterns through isotherms? Yeah, बताओ, doubts है? All good? अंगड़ाई ले रहे हो गंदा वाला? कोई बात नहीं. हिंदी में we call that as कातिल अंगड़ाई. Indian monsoon, CS Parvaz. Anybody any doubts online, offline? So when students take admission, this is one of the criteria. Sir, मेरा doubt clear होगा कि नहीं? पूछो. Okay. You're asked to ask your doubts now or even after class. You can ask me doubts tomorrow also. Every morning, I start the class with 10-15 minutes of doubt clearance. Fine. If you have any doubts, let me know. Okay, let's move on. So I said the temperature pattern जो है, one is the surface pattern, and that's what I was discussing right now. The averages we have taken. No, that's only for some comparison. The isotherms are never permanent. They will change. They will shift. The place will never have same temperatures, right, Neeraj? So isotherms are not permanent. Okay. They will shift as the land or the water becomes warm or cold. Okay. What's the surface pattern? We understand this. And what is the vertical pattern? Vertical pattern essentially is the temperature pattern through the vertical layers of the atmosphere. Okay. In this, there is one concept called as inversion of temperature. Okay. There's one phenomena called as inversion of temperature. So take a fresh page and have a heading. Temperature inversion. हाँ बताओ. Sorry, any doubts? Yes. Surface pattern is the horizontal pattern, correct. Surface pattern is the horizontal pattern, correct. Okay. Come towards the temperature inversion. Okay. सुन लो पहले, then I'll go back and explain. So what we have said is, for the atmosphere, what is normal? Normal, I am assuming with the troposphere. What's normal is, the lower layers are warm, the upper layers are cool, uske upar it is even more cooler. So this is the lapse rate. This is normal. But sometimes, because of some local conditions, it's possible, rather than this, the surface can become cooler here. वो यहाँ पहुँच जाएगा. So इस line में I am plotting temperature. Say 0, maybe 5, 10, 15 degrees, 20 degrees, 25 degrees, 30 degrees temperature. This is warm. You come here, it has become lesser. You come here, it's become even lesser. But ये case है where this is not the pattern. The temperature is less. Above layers is a bit more warmer. This is a bit more warmer. This is even more warmer. उसके बाद में it again becomes normal. So when the lapse rate is changing, we call this as inversion of the temperature pattern. And this inversion can happen anywhere. You have seen, this was the lapse rate, troposphere. It should have continued like this. The stratosphere has this lapse rate. ये कुछ नहीं है तो यही तो है और क्या है? So stratosphere is also an example of temperature inversion. ये कहीं भी हो सकता है. It can be at the ground level. It can be at this part. It can be in the stratosphere. This also is a pattern for the thermosphere also. Okay, write down. Temperature inversion is a phenomena. Temperature inversion is a phenomena where there is a reversal of the lapse rate. Where there is a reversal of the lapse rate. That is, rather than the temperatures cooling with height, rather than the temperatures cooling with height, the temperatures can increase with height. The temperatures can increase with height. Next point. This phenomena can happen at any locations. This phenomena can happen at any locations. It can be a surface phenomena with surface inversion. It can be a surface phenomena with surface inversion. Or it can also be in the upper atmosphere. Can also be at or in the upper atmosphere. Inversion can be at surface or can be in the upper atmosphere. Upper atmospheric temperature inversions. इसके एग्जाम्पल्स हैं द स्ट्रेटोस्फेयर, इसका एग्जाम्पल है द थर्मोस्फेयर. द स्ट्रेटोस्फेयर बिकॉज ऑफ द ओजोन लेयर, द थर्मोस्फेयर बिकॉज ऑफ द आयंस. द अपर एटमॉस्फेरिक टेम्परेचर inversion, stratospheric inversion because of ozone, or thermosphere inversion because of the ions. Both examples of upper atmosphere. Even the isothermal layers. Remember the tropopause? याद आ रहा है? Tropopause भी एक टाइप का inversion ही है. There is no longer cooling with height. Okay. Tropopause, the stratopause, or the mesopause. All of these are also types of inversions. Okay? The upper atmospheric inversion. The next is the surface inversion. The surface inversion. Now, this basically means the air near the surface has become very cold. It should have been warm, but it becomes very cold. इसका reason क्या हो सकता है? Maybe there is a cold wind moving in. A cold wind is coming in. So this was the surface. This should have been warm, but some cold wind has come here. Okay, so this has now become cooler, inversion, and then again lapse rate, because the cold wind moves in. Like, remember, Mistral comes in, or maybe Bora wind comes in. Okay, examples of cold wind moving in is, so the cold wind called Bora has come in. The cold wind like Mistral has come in. Okay? Mistral can move along the river valleys. It can be because of cold air sinking along the slopes of the mountains. Cold air sinking along the slopes of the mountains. Okay. So imagine this is a mountain and this is night time. Night time, the land becomes very cold. Because of this, the air becomes very cold. Air, cold is dense air. It starts to sink and it reaches here. And this piles up here. यहाँ से एक और mountain है. Again, it is night time. Land is cold. Air is cold. And the core air starts sinking and coming here. Okay. So this type of wind, where the wind comes from the mountain towards valleys, we call these as mountain breeze. Mountain breeze can cause inversion at the valleys. Okay. So inversion because of the mountain breeze. Night time, less insulation, mountain height पे है, land is very very cold. Atmosphere is heated from below. अगर land बहुत cold है, तो air भी बहुत cold हो जाएगा, right? If air is cold, cold air is heavy, is dense. It will sink along the mountain slope. Okay, it happens in the night time. That's the reason why we say that valley floor is not a good place for habitation. If you make houses here, it can become chilling cold because of the cold mountain breeze. Add on this point here, that because of valley inversion, it's also called as mountain breeze, and this is called as a valley inversion. It's called as valley inversion. Okay, because of valley inversion, the valleys are not preferred locations for settlements. Because of valley inversion, the valleys are not the preferred locations for settlements. So people prefer making houses on the slopes, yahan bana lo, but not at the valley floor. So people prefer making houses on the slopes, not on the valley. Okay? Yes. This is also called as katabatic winds. Correct. The sinking wind is also called as katabatic winds. Anabatic is rising, katabatic is sinking. Cold है, काटता है, katabatic है. याद रहेगा अब? Okay. Otherwise ऐसे याद रखो. No, it's not seasonal. ये daily basis पे है. Pravash, every day, every night, the wind will come down. Katabatic winds. Okay. Now, the third type is influx of a cold front. One is the cold wind has come in. Second is ये भी cold wind है, but coming from the mountain heights. The third is a cold front is coming. Cold front, you can remember this as that there is some zone of interaction between a very large air which is cold and a very large air that is warm. This interaction zone is called as a front. And when the cold one pushes, this is called as the cold front. I'll come back on this again while discussing fronts. For now, that's okay. Okay. What's a cold front? Cold front is, likh lo, is a zone of interaction. Cold front is a zone of interaction between very large bodies of air. A zone of interaction between very large bodies of air with the cold air mass pushing. With the cold air mass pushing. So if this is pushing and the observer, a person stands here, he can see the cold wind is coming. It's not same as this wind, ye alag wind hai. It's a local wind, a small area mein. This is much larger systems. So for an observer, he will see the cold air is coming towards him. So also will cause inversion. Okay, so we have got inversion because of cold winds moving, inversion because of mountain breeze or katabatic winds, inversion because of cold fronts. In all the three, it is horizontal movements. It's actually wind. ये भी एक type का wind ही है. In all the three. So when things move horizontally, we call that as advection. So all the three are examples of advection inversion. Write down. The above three examples are horizontal motions of air. The above three examples are horizontal motions of air and therefore called advection inversion. And therefore called advection inversion. Okay. Now this can also be called as a frontal inversion. It's also called as frontal inversion. So valley inversion, advection inversion, or a frontal inversion. All fine here, all of you? No. This is not vertical. Watch here. This wind is coming from top towards bottom, but this is still along the surface ही है ये. Okay. Advection is anything moving along the surface is advection. But आपके केस में क्या किया? Surface ही टेढ़ा है. This also is advection going on. It is not convection. Okay. So even the mountain breeze is one example of advection. It is a wind. ये भी wind है. This also is a one type of wind. It's not vertical rise and sinking of air. Fine, all of you? Fine then. That's for today. Summarize your notes on daily basis. We'll take up tomorrow again. I'll repeat it. आप revise कर लो एक बार. All the notes are there. And make a summaries. Tomorrow I'll continue and explain again if required. Bye.